So, you and your friend are walking in the park, and you see a couple of kids playing catch with a ball, and your friend comments that none of this would be possible without a very special force called gravity. So you agree, because gravity attracts that ball towards Earth, making it fall into the player's hands. Alright, so as many of us hopefully know from Newton's first law of motion, an object will move forever until another force acts upon it. And this force can be gravity, in this case the ball falling towards the Earth, or it can be friction, be due to air molecules, or it can be like laws of thermodynamics. Okay, let's not complicate things too much. Later that same day, your TV was on and you stumbled upon a program you never watched, the science one. And there was a program about gravitational waves. You suddenly look up, paying attention. The physicists in the show mention Einstein's theory of general relativity and how they finally proved it. And the thought crossed your mind, why are there two theories of gravity? Isn't one complicated enough? Let's untangle this gravitational mess and start from the beginning. From an apple. Yes, quite literally an apple. So, one sunny day in 16th century Britain, a young fellow named Sir Isaac Newton admired apples falling from trees. He looked at the falling apple and thought about why it was falling. Yep, a true scientist. So, what did he do? He then described gravity, one of the four fundamental forces in the universe that acts on objects with mass. And that means every object. So you are attracting that pencil across from you, but it isn't moving. Earth's gravity is so immense, and you and the pencils is so insignificant, only Earth's gravity is noticed. That's pretty sad. So the gravitational interaction between objects and Earth can be described by Newton's law of universal gravitation. There's just one small problem here. Newton does not know how gravity actually works, the mechanism behind it. He could only describe its effects. So here comes Einstein. He proposed a new model. Because Newton said that gravity was a force of attraction, this didn't work out in every situation, like in fast speeds or at large scales, so Einstein said that the universe was a fabric where objects reside, and objects with mass cause disturbances in the fabric. They dip. So the sun has a huge gravitational well where all the planets are attracted to and they keep falling towards it, but they never actually go through. But what about gravitational waves? What was the TV talking about? So these are waves caused when two objects orbit each other in the fabric of space, and when they explode, they cause ripples or waves in the space-time that make the universe. So we detected two black holes orbiting each other that made gravitational waves in 2016 using LIGO, and Einstein was right. So Einstein's theory can actually explain everything we see on Earth. It's just way too complicated. So we stick to Newton's gravity since it works great. We use it for launching rockets, we use it for fundamental physics on Earth, like falling bodies, etc. Newton wasn't forgotten. But when it comes to the scale of the universe, we'll stick to Einstein. However, the physics behind some objects' existence doesn't quite align with either theory, like black holes or the beginning of the universe. Unfortunately, our current understanding of astrophysics and physics is incomplete. We may need an entirely new model for gravity to explain these topics in the far future. But for now, Newton and Einstein have their respective places in physics as pioneers of gravity. Thanks for watching.